Recently, I got given a number of slightly defective 8 terabyte hard drives. I have a SATA to USB converter, and if I plug that in and I turn it on, we can see here that it says disk spinning up. So the drives are alive. That probably means there's just read or write errors. I found a program called Bad Blocks that searches a disk for blocks that it couldn't read or write properly, and it makes a list of those. Then when you make a file system on the disk, you can tell the file system creation program, hey, don't use these blocks. ls block, the drive I've just connected, is at SDE, bad blocks dev SDE. It says permission denied. We need to run it under sudo so it has root privileges. We need to set the block size. If you do sudo fdisk list, it tells you that the physical block size is 4096 bytes. So bad blocks 4096. So I can hear it running, I can see the light on the hard drive flashing, but it's not printing anything out. The man page for bad blocks, we go down a bit, there is a -s option which says it will print out status as it's going. Now we can see that it is 0% done and 4 seconds have elapsed. That percentage done goes up very, very slowly, and that's because this is probably going to take a day, which is not an issue for me. I'll just leave it running in a corner and then I'll come swap it over to the next hard drive. This status doesn't print out an estimated finish time. We're going to build a program called Big Bad Blocks, which wraps this and outputs an estimated completion time. So let's start off by just running the program exactly the same in Python using subprocess. And it's running the same sort of output, and I can press Control-C. If we go back to this command and we just send the std to dev null, nothing's output. So now we know that Bad Blocks is writing the status not to the std out, but to the std. Now, because we want to capture the output as it's running, not get all the output at the end, we can't use subprocess.run. We have to swap to managing the process ourselves. So we use subprocess.popen or poppen. So this is very much the same as our previous version with subprocess.run, except for now we're managing the process ourselves. And at the moment, all I'm doing is just waiting for the process to end. I check the return code and raise a called process error if bad blocks failed for some reason. This try finally, it just means that if we interrupt this process, we still get the bad blocks terminated. It should look exactly the same. At the moment, bad blocks std is going onto the terminal, but we need to capture that in Python. So let's capture it using a pipe. We can see here that my type checker is complaining that read is not a known attribute of none. Std could be none if I hadn't passed std process pipe here. So let's just assert that that's true to make the type checker happy. So it's running, I can hear the hard drive going, but nothing's being printed out. The status is nowhere to be seen. If I Control-C it, suddenly it prints out right at the end. But that's no good to us because we want to monitor the status of check blocks as it's going. So we need to change std into non-blocking mode so that we can read in data as it's available. It just prints none, so why did it do that? So the process was running, it set it into non-blocking mode, and then it tried to do a read immediately. But there was nothing there. Bad blocks hadn't written anything to the std. So read in non-blocking mode, read returns none if there was nothing to read. So what we have to do is put this in a loop, and if it's none, ignore it or go around again. So while true, we're reading the data. If there was no data there, we just go around the loop. There we go. Look, it's working. It's printing out the status as time goes on. But if we look at my CPU usage, we can see 100% CPU is this program. And that's because this while loop is going around as fast as the CPU will let it. Because we don't want to call read until there's actually data there. So let's change the way the loop works so that it waits for data. we're using select to say, put my program to sleep until std has data to read. And we can see it is printing out data as it's available from bad blocks. And if we look at our CPU usage, our Python process is nowhere to be seen. So that's that problem solved. But one thing you might notice, this code's unreachable because this here is an infinite loop. When I press Ctrl+C, that delivers sigterm to bad blocks. So bad blocks has exited, but my Python program hasn't. And you see that we're actually getting an empty byte string over and over and over again. When the file is closed, that's indicated to us by the empty string. When we see that empty string, break out of the loop. Okay, so that's running. I press Ctrl+C to kill bad blocks. Our program detected the empty string, broke out of the loop, and exited. We interrupted bad blocks, but Python exited cleanly, and really we should have seen a called process error. And that's because by the time we got to this check here, the process hadn't actually finished yet. Return code was none. So what we need to do now is add in a proc wait here. Then we got our called process error as desired. This is the string we're looking for here. Let's take this chunk of data that was printed out. Now we are processing bytes directly, we're not converting it into strings. So we need a byte regular expression, which you create by passing your pattern as a byte string rather than a string. We're not looking to match the whole string, we're searching for a status in the data that's been output. So we're going to use search, pass it the data, and print the match. So let's just see what happens there. So that did match because everything matches the empty string. One or more digits 0 to 9, followed by a dot, followed by more digits, followed by a percent. Because if we want to match a literal dot in a regular expression rather than any character, you need to do a backslash dot. But backslash is also the escape character for a Python string, so they're fighting with each other. The way around that is to just use a raw string. Let's run this again. Okay, that did match. Then it's followed by space, then done, then a comma, then a space, then minutes, colon, then seconds, then space, then elapsed, then a literal dot, then a space, then a literal open bracket, then another digit, and then another digit, and then another digit, then the word errors, then a literal close brackets. That matches, and you see the whole match was everything we wanted. So I don't tend to write regular expressions like this. I write them in a thing called verbose mode. At the moment, you see I've got this space here. That space is part of the regular expression and will match this space here. But in verbose mode, white space is completely ignored. So it allows you to format your regular expression, which means we can switch to a triple quoted string and we can start formatting this nicely. But we do actually need to match a space. So how do you match an actual space? You do character group that contains a space. So that's done. Then we need to match a space there. Then we're matching the elapsed time and then some separator stuff. And we need to match a literal space there. And then a space there. So that should still match. No, I've made an error somewhere. So we're matching digits dot digits percent space done space digits colon digits space. I'm missing a space there. Okay, so that should still match. Fantastic news. Now we need to extract out the information from it. So we do that using groups. There's one thing we want. We're not interested in the percent sign, so keep it outside the group. You create groups by surrounding parts of the regular expression in brackets. We're interested in the elapsed time, and we are interested in the read errors, the write errors, and the data corruption errors. And let's print out group. When regular expressions get complicated like this, it becomes difficult to remember which index group is which piece of information. So I tend to use named groups. So I do, at the start of a group, question mark P, open angle bracket. This is the done. I realize we probably want to capture the minutes and seconds separately. group dictionary by doing match.groupDict. Nice. Now, I happen to know that if you run this command for over an hour, you actually get an hour here, and this regular expression now doesn't match. So we need to add an optional group for hours. So now that should match. And we have our hours in there. So let's go back to before the hour. What's that like now? That no longer matches because we need to make this whole bit optional with a question mark. Good, and we can see that hours is none. We can extract the information from the matched text easily using groupdict, but it's still not in a very nice format for us. We want to put it into a Pythonic object so that we can easily deal with it in the rest of the code. So let's make and it has done, which is a float. It has elapsed, which is going to be, believe it or not, a time delta. Now we want to turn our match into a nice status object. Take the done group, convert it to a float, and at the moment it's a percentage, but it would be better if we were dealing in a ratio. So we're going to divide it by 100. Elapsed is a time delta, and the hours are groups get hours. Hours might be none, so we default it to 0. Minutes is simple. Again, groups, minutes. So now we have a nice Python object with all the data in the right types. So let's transplant this back into our original program. So we've just taken the code from there and put it into a function called try extract status. We pass in the bytes we get from read. We see if we can parse out a status and return it. Then down here, if we do get a status, we're just going to print it out. There's our first status. There's our next status. There's another status. They are all coming out nicely. Now you might notice when we run this program, the statuses are printing out weird. They're not at the start of the line, and that's because bad blocks is doing something strange with the stud in. And we could stop it from doing that by just hooking up the stud in to devnull. So we've been lucky so far, and each time .read comes back with a new byte string, that string has contained a complete status. And it's only contained one status. But there's actually no guarantee that that's the case. It might be that our process, Python process, gets stopped and multiple statuses are available to read, or that an incomplete one is available to read. So what we need to do is buffer up the incoming data, and then once we see a status, we need to get rid of the buffer up to that point. We can do that using a byte array. So search doesn't have to take just bytes or string. It can actually take anything that supports readable buffer. Readable buffer is a protocol inside of TypeShed that doesn't really exist at runtime, so we have to do this trick. It only gets imported by the type checker. This symbol won't actually exist at runtime, and we will get an error. So we have to change the way that annotations work so they are lazily evaluated. In Python 3.14 and above, you won't need to do this because they are lazily evaluated by default, but I'm on 3.13. So if we did find a status, we're done with all of the buffer data before that match, so we get rid of it. Now we just need to handle the case where there is multiple statuses in the buffer. Simple enough to do is we just stick this in a while loop, and we break if the status was none. You must remember to call it. Well, that's not going well. We are looping round forever, it seems. My bad, that should be on the outside of the loop. Otherwise, every time we extract the status, we stick it back on again. All right, that's better. changed. So we need a timestamp for the status, which is going to be a date time. Start time, which is a date time. We're going to have end time. This is another date time. We are going to have elapsed, and we are going to have remaining, which is a time delta. We need the timestamp to calculate some of the others. So the start time is time now minus the elapsed time. Duration, which is a time delta. The duration is the elapsed divided by the done. Then the remaining is the duration minus the elapsed. And the end time is the start time plus the duration. Instantly, we hit a problem. Integer division or modulo by 0. And that's because at the start, done is 0. So we can't calculate duration, which means we can't calculate end time or remaining either. One solution would be to make them optional here. But here's the thing. If one of these is defined, then all of the others will be. But that information isn't captured by the types here. It's saying that end time, duration, remaining can be specified or not specified independently. And that's not the case. We can create another data class. Might as well just call it end. And then either we specify the whole end information object or we don't. Let's give that a go. Probably get rid of the divide by 0 error. Okay, that's good. Then we can see on the first one, this end object was none. And then once the percentage is no longer 0, there you go. Now we have more data output. So now we need to output this information nicely, which we can do using a library called rich. And from rich, we want live and we want table. It'll be clearer once you run the program, but we're constructing a table. In the left-hand column, we have all of the names of the fields, and in the right-hand column, we have the values themselves. So let's run it. So we just have to wait for the percentage to be non-zero, and then from that point, we can start estimating the completion time. So we're going to make a small argument parser, which is just going to take on the command line the file name to write the bad blocks list out to. So we just tell bad blocks to write to that file. So if we now do Python big bad blocks and we say bad blocks.txt and we just run it until we see that one read error, it shouldn't break the output like it did there, and in that file should be one number, which is the bad block. So whilst that runs, this is not how I would write the program in real life, but I've just tried to write the code that contains the interesting bits. Let me know in the comments if in episode 2 you'd like to see a new small utility be written, or you would like to see me take this code and turn it into what I would call proper code. So there's our read error. Stop the program. Let's have a look at our bad blocks file. There's our integer.